Continuing with Unit 5 Progress Check Part C, we're going to go with number 4 here. It says the acceleration in meters per second of a race car is modeled by this function where t is measured in seconds. What is the car's maximum acceleration on the time interval 0 to 6? All right, so we want maximum acceleration. Well, we want to find the maximum of something. We take the derivative, set it equal to 0. So we're going to take the derivative, which is 3t squared minus 15t plus 12. And we want to set that equal to 0. At the same time, let's go ahead and divide both sides by 3. So we have t squared. So dividing that by 3, minus 5t, dividing 12 by 3 is 4. This factors to t minus 4 times t minus 1. So either t equals 4 or 1. Well, let's put 1 first. All right. So we have a couple of our candidates. So we have accelerating from 0 to 6 seconds. And so what we can do here is we want to see what's going to give us our maximum. So our maximum acceleration, we'll use our candidates test. So we know we have our endpoints of 0 and then 6. And we have these couple other options of 1 and 4. We can go ahead and plug those in, and we just want to find which one's the maximum. So if we put 0 into our function, we get 10. So that's nice and simple. So we're putting it into our acceleration function. Let's highlight it here. All right, putting 1 into our function. So putting 1 into the function, that gives us 1 cubed, which is 1 minus 15 halves times 1 plus 12 times 1 plus 10. So 15 halves is 7.5. So we have 1 plus 12 plus 10 is 23. 23 minus 7.5 is 15.5. All right, so that's the maximum so far. Plugging in 4 cubed is 64. 4 squared is 16. 16 will cancel with 2, so negative 15 times 8 is 120. And then 4 times 12 is 48, plus 10. Now this seems like it's going to be pretty small. So we have 64 plus 48, that's 112, plus 10 is 122, minus the 120 is 2. So that is not the maximum. And then plugging in our last one, 6. 6 cubed, 6 times 6 times 6 is 216. Minus 6 squared is 36, canceling with 2. This is 15 times 18. Plus 12 times 6 is 72. Plus 10. 15 times 18. So that's 270. So we got 216 plus 72 plus 10. That's 298 minus 270 is 28. So this is 28. So our maximum is 28. So at 6 seconds. So the maximum acceleration of a race car is Nope, that is not right. That's written wrong, so be careful. So it says the acceleration is 6. That is not correct. The acceleration is 28 at 6 seconds. So our answer for that is D. All right, moving down to number 5. The cost in dollars to order X units of a certain product is modeled by C of X equals 5X squared plus 320. According to the model, for what size order is the cost per unit minimum? So that is kind of a tricky question. It's cost per unit. So this gives us total cost, but cost per unit would be to divide this by how many units are sold. So the function we want to work with is 5x squared plus 320. That's our total cost divided by x, because that's how many are sold, and that would give us our cost per unit. And we want to find a minimum, and so we'll want to take the derivative of this. It might be easier to use this common denominator and realize that this is 5x plus 320 over x. And so we want to take the derivative of that. So I'm just put new for our new function. And so the derivative is 5. A lot of times we think of this as 320 times x to the negative 1. So this is minus 320 x to the negative 2, or 5 minus 320 over x squared. Well, cost per unit, we obviously don't want to sell 0 units. With this is where we can't sell negative units. So kind of think of our domain as x is greater than 0. So x equaling 0 makes this undefined, but after that, we're okay. So let's set this equal to 0. So let's add the 320 over x squared to both sides, multiply both sides by x squared, divide by 5. So 320 divided by 10 is 32, so divided by 5 would be 64, or you could just divide it. And you get 64. So x equals plus or minus 8. Well, we definitely don't want to be negative 8. We can't do negative units. So x equals 8 is our option. So in order of 8 units, and actually, yeah. Gives us our minimum cost per unit. Because that's our only critical number. And so therefore it needs to be a minimum. All right, number 6. I'm going to go ahead and erase. Well, let's see what we can do here. So let's not use this. All right. An electrical power station is located on the edge of a lake, as shown in the figure. So here's the electrical power station up there at the top. An electrical line needs to be connected from the station to an island in the lake that is located 4 miles due south and 1 mile due east. It costs $5,000 per mile to install an electrical line on land and $10,000 per mile to install the electric line underwater. C represents the cost function, which the following methods best explains how to determine the minimum cost in dollars for connecting the electrical line from the station to the island. All right, so we know this is going to be $5,000 per mile by land times how many miles on land distance, plus $10,000 times the water distance. So that's what the cost is going to be. And the idea is we could go all the way down here on land and then across here on water. That would be 4 miles times $5,000 times 1 mile times $10,000. So that would be one option. But some other options would be to just maybe come down this far on land and then come across here on sea. Now, we are not counting this little bit of stuff on the land here. We're just coming straight down the land and over to the island. So there's a couple different ways to think through this. So we have to look at their options to help us figure out. We could either make our variable x here, like how far from the island to the land, or we can make x here how far it is on land. And so we need to see which they chose to do. And so we can look down here and see this 5,000x, 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 and 5,000x. So they're choosing x to be the land distance. All right, so because it's multiplied by 5,000. So x is our land distance right here. Well, what is this distance then? All right, well, we have a right triangle here. Let's go to blue. We have a right triangle where we know this is 1. Well, this vertical distance here on our paper is the total 4 miles. It's tough to see in there. 4 miles minus the x up there. And so we can use Pythagorean theorem to find this length here in the water. So we know, let's just call this A, or we can call it W for water. We can say W, well, we can say 4 minus x squared plus 1 squared is equal to the distance in the water squared. We can take the square root of this. And so the distance in the water, we could put plus or minus, but we want a positive distance. So the water distance is 4 minus x squared plus 1. And so thinking through that, back up to our cost function, our cost is going to be $5,000 times x plus 10,000 times the square root of 4 minus x squared plus 1. And that's helpful because that eliminates part C and part D, because that's not the function that they used. All right, so let's see if x equal this function, which we figured out. Solve for c prime of x equals 0. So that's finding the critical number. And find the values of x where c prime of x changes from a positive to a negative. So this is our slope. C prime of x is our slope. And so the only difference in A and B, let's highlight it, is that it's changing from positive to negative or negative to positive. So we are looking for a minimum cost. So we're looking for a minimum. And so when we look for a minimum, we have the derivative 0. To the left of it, we want our slope or our derivative to be negative, and to the right of it, after it, we want it to be positive. And so we want to go from negative to positive. So our answer here is B.